Project Drawdown. I don't know their the other group.
I forget what it is, but I
We'll
looked
look up
through
and
the
see.
universities to see if Argonne was involved, since we're part of the University of Chicago, and it was not
Yeah.
listed, but U of I was.
Okay.
And
So
you know, back in 2016, there was a big effort by, let's say, groups outside of the government to download and archive everything on climate change that the EPA and the DOE had on their websites
yeah,
before it disappeared.
I remember that.
I downloaded about 100 gigabytes worth of the data.
Good for you.
I just checked Marianne's email to me, and I'll put, it won't be a link, but I'll put in the chat, it's Bloomberg Green Virtual Festival. So that should make it findable for anybody
Perfect.
who wants to.
Yeah.
Thanks, Rick, because I am really not very good at doing the chat.
Yeah, so not a link, but information anyway.
Okay, shall we
Isn't too good.
start, Rabbi?
Yeah, I think so. I just got us live on YouTube, so you can watch us there as well if you'd like. But no worries, you can be here.
Okay.
Let me actually turn this to speaker view and share my screen.
We are going to mute and.
Oh yes, and if everybody could please mute themselves so we don't have much background noise.
Excellent. I'm the only one who's allowed to speak right now. Okay, the first slide is just shows us the flyer that went out. So if you think you're attending a different Zoom meeting, you're now in the climate change meeting. And we're happy that you're here, whether you intended to or not. Next slide, please. Just want to make a few quick comments. My name is Marianne Mintz, and I'm a member of the Environmental Task Force, which is the group that is behind today's event, Trees of Life Against Climate Change. And just note that except for whoever is speaking at any particular time, all of the microphones are muted, and that we encourage you to submit questions via the chat box. And the host, who is Rabbi Camel, will direct them to the speaker. Time permitting, speakers will respond to simple clarifying questions immediately following their talk. But we really encourage you to hold your questions to the Q&A section of the program. And just note that today's event is being recorded. It will be posted to the Temple's YouTube channel, and it'll also be available via the webpage for the Environmental Task Force. And the Environmental Task Force is a new group. It's part of the Social Action Committee, and you can access it via the Temple's website under Tikkun Olam, and just keep scrolling down until you find it. There's information on today's event, also some other events that we're involved in, and on the task force in general. And as I said, the link for the YouTube recording of today's event will be there, as well as copies of all of the presentations. And just wanted to mention that the title for today, Trees of Life Against Climate Change, is kind of it basically reflects the name of the temple, Congregation Etz Chaim, Trees of Life, and our activities that we want to get more involved in fighting climate change. And today's agenda is, as you'll see in a moment, is very tight. We'll try to stay on schedule, but please bear with us if we do go over. Next slide, please. As you see here, this is the agenda. Following my brief comments, Rabbi Camel will welcome us, and then we have our two speakers, Trent Ford and Lydia Scott. Trent comes from the University of Illinois. He's the Illinois State climatologist, and Lydia comes from Morton Arboretum, and she's the director of the Chicago Region Tree Initiative. Going from the broad, we're then going to go, as I said, into the local, and then we're going to move out to the broader picture. Rick Schoenfeld will talk a little bit about work that's being done with tropical rainforests around the world, and then we'll move to our question and answer section. At 2:30, we hope to adjourn, but it's possible we might go on. We have a group that is quite knowledgeable and interested, and we'll continue the conversation if there is enough interest. However, if you have to drop off, just bear in mind that there is a recording and you will be able to listen later. And with that, I'm going to hand the microphone over to Rabbi Kamel, our host. He's been our spiritual advisor on the Environmental Task Force. He's been with us as we've been organizing this event, and we thank him for his help and assistance. And off to you, Rabbi.
Well, thank you so much. And thank you everyone for being here today, taking time out of your day, especially right before this very holy time of the high holidays, as we think about what we can do better as we go throughout the year. And we know as we come to this time, this end of Elul, beginning of Tishrei, beginning with Rosh Hashanah just on Friday night, we know that we can do better by our planet. We know that we can be better to make to address climate change as a real issue and make sure that our policies and our actions as individuals and as communities and as governments reflect that as a real issue and make real change, so that our Earth is here for as many more billions of years as we need our Earth to be here for. We know it's come from 4 billion, but we want at least another 4. We, as Marianne mentioned, we are called Congregation Eitz Chaim, the Tree of Life Synagogue, and it is very fitting that we are going to be learning about trees and how essential they are, of course, to our life, with 2 wonderful speakers here today. I do want to just open up with a quick blessing, the Shechianu, as we are coming here today all together, and since it's a newer committee. It's a Shechianu moment that we are able to come together and be able to have our first event that is really going to be for this lasting change. Baruch atah Adonai Eloheinu melech haolam shechianu v'kiyamanu v'higianu lazman hazeh. Blessed are you, Adonai, our God, ruler of the universe, who has brought us to this special moment in time. So it is now my pleasure to invite as our first speaker. I'm sorry, I just have to move a couple of things around so I can read it. Dr. Trent Ford is a member of the UIUC and the Illinois State Climatologist. He and his team provide information online through traditional and social media and by speaking to interested groups across the state. Trent also conducts research on the climate system and current conditions and studies climate change. Trent earned his bachelor's from Illinois State University and his master's and PhD from Texas A&M University. And we are very happy and appreciative that he is here to share his knowledge with us. I'm just going to exit out of that shared screen and invite you on up to speak and unmute yourself, Dr. Ford, and I will go over to your slideshow.
Okay. Okay. Well, thank you all for inviting me today to come speak and discuss with the faith community here about climate change. I'm going to set a timer so I don't ramble on as I intend to do. So today what I'm going to do is present information about climate change, as I say, science and impacts. So kind of the fundamental science behind climate change, and then impacts that are a mix of impacts specifically to Illinois, and even more specifically in some cases the northeastern corner of the state, as well as more global impacts that will trickle down to this part of the state. So, go ahead and next slide. Okay. So I have to begin any climate change talk with this slide. This is a simple schematic of the Earth's energy balance. And in the end, what's driving climate change, which is global warming, is an energy problem. So we have a number of gases in our atmosphere. Certain gases, the term is greenhouse gases, they let in the shortwave radiation coming in from the sun. But those same gases that are in the shortwave radiation absorb, or often folks will say trap, the outgoing terrestrial radiation. So that shortwave radiation comes in from the sun, it interacts with the atmosphere, interacts with the land surface, and a sizable chunk of it is sent back out into space as terrestrial radiation, therefore providing a long wave and shortwave energy balance. When the concentration of these gases, namely carbon dioxide, CO2, CH4, which is methane, and the gas form of water, H2O, as their concentration in the atmosphere increases, the amount of long wave radiation, the terrestrial radiation that is emitted that stays here on Earth increases. And so the concentration of these gases really determines largely our Earth's temperature. And that is not over what's called the Anthropocene, the era of human changes, human-induced changes to our climate, but over Earth's history overall. Go ahead and go to the next slide, please. So what this is showing here, this plot is from our long-term carbon dioxide or atmospheric observatory in Mauna Loa in Hawaii. And what we see is that since the beginning of the 1960s, when these measurements began in Hawaii, we see a consistent increase in atmospheric carbon dioxide concentration in parts per million. So June 2020, we're at 414 parts per million. The first observation at Mauna Loa back in 1957 was at 314 parts per million. And go ahead and go to the next slide. I believe we can put this in longer context. So remember, 414 parts per million of our current carbon dioxide concentrations. What this plot is showing here, the top line is really the one I want you to focus on, the red one. What this is showing is observed carbon dioxide concentrations from the Dome C ice core taken in Antarctica, going all the way back 800,000 years before the present. Now, the great thing about ice cores is that because the air in the atmosphere at the time that the ice formed will trap those air bubbles, we can extract direct observations of atmospheric chemistry going back almost 1 million years in the past. And so what you're seeing in that top line is not a reconstruction or an estimation of carbon dioxide, but a direct observation of past carbon dioxide concentrations. So with that, I will direct you to the y-axis, or the vertical axis there, that's showing that over the last 800,000 years, the Earth has never seen carbon dioxide concentrations exceed 300 parts per million. And as I mentioned before, earlier this year, we are 414 parts per million. And what you can see here also, lots and ups and downs, lots of variability. There's lots of drivers of variability we can discuss in the discussion. However, we haven't seen in a 100 to 150 year period the increase in carbon dioxide that we see today. There's no precedent for it in this record. So go ahead and go to the next slide. Thank you. So, so increases in carbon dioxide concentrations really since the mid 1800s. So what does this do? Well, it traps more of that outgoing long wave radiation, and it increases our global average temperature. And that's what this is showing here. This is the combination of direct on-ground observations and satellite observations of air temperature, global average air temperature, expressed as an anomaly. And you can see that precipitous increase since the early 20th century that we've seen. And this is what is known as global warming. Now, a lot of times we'll hear global warming and climate change used synonymously. And I like to kind of put a stop to that use because they are very different. And by using the term global warming to describe changes in climate, it can imply that everywhere is getting warmer at the same rate, which we know is not the case. So global warming, which is caused by that increase in carbon dioxide concentrations, what that does, go ahead and go to the next slide, please. What that does is it causes changes in different regional climates that react differently. And so global warming causes change in what we consider our normal weather patterns, our climate, and that's what climate change is. What this figure here is showing is from the International Panel, Intergovernmental Panel on Climate Change, IPCC. What this is showing is the forcing of the change in carbon dioxide concentrations and therefore the change in temperature over the last 150 years. And what this is showing is that about 90 to 95% of that change in temperature directly related to the change in carbon dioxide concentrations is from an anthropogenic forcing, or that is called human induced. So all of the natural variability of the climate system, volcano activity, sunspot and solar activity, all of that washed out. About 90 to 95% of our current warming that we've seen over the last 100 years is directly due to humans. So that's why I call human-induced climate change. So go ahead and go to the next slide, please. And so we have this increase in global average temperature, and that changes global scale wind patterns, changes the way that the water, the hydrologic cycle interacts, and how oceans, atmosphere, and land interact to change climate in very different ways. And so again, global warming causes climate change. What we're going to talk about, what I'm going to talk about today, is the climate change part of it and how that has been affecting how our climate here in Illinois has changed and is projected to change over the next century or so. But go ahead and go to the next slide, please. All right, thank you. Go ahead and skip this one. You can go to the next slide. So this is, we're going to talk about temperature first. So what we're seeing here is observed changes in temperature. On the right, it's county scale maps in Illinois. And I break down the temperature change observed over the last 120 years into the different, our 4 climatological seasons. Now, these are different than our celestial seasons, which is important. So winter is December, January, February. Summer is June, July, August, so on and so forth. What we've seen overall when we take it over the entire year is that statewide annual average temperature has increased by about 1/10 of a degree Fahrenheit per decade since the late 1800s. So we're about 1 degree to 1.5 degrees warmer here in Illinois today, based on average annual temperature, than we were at the turn of the 20th century. With that being said, warming trends vary quite a lot seasonally. So warming trends in winter and spring, as you can see by the maps, are much larger than they are in summer and fall. And actually, you can see a few counties there in southeastern Illinois along the Kentucky border that have actually observed an overall cooling trend in summer and fall. And when we take the overall statewide average changes in temperature, what we see is that actually summer temperature has increased the least. So and this again is pretty homogeneous statewide. What we see is that winter and spring temperatures have warmed to a much larger extent than summer and fall. I break down the different trends over the last 120 years in this table down here at the bottom. These are showing changes in temperature, so it's degrees Fahrenheit per decade trends between 1895 and 2019. And positive numbers in red indicate warming. The one negative number in blue indicates cooling. So I like to do this and break it down by not just showing mean temperature, but also daily maximum and daily minimum temperature, because that's what's really going to affect us here. What we've seen is that in winter and spring, and to a lesser extent in fall, maximum and minimum temperature trends generally tracked mean temperature. Minimum temperatures increase a little bit more, but it's about the same. In summer, we actually see a reverse trend. Summer maximum daily temperatures have decreased over the last 120 years, whereas minimum temperatures have increased. And a lot of that can be attributed to increases in humidity and cloud cover that make for overall cooler daytime maximum temperatures, but warmer nighttime minimum temperatures. Go ahead and go to the next slide, please. All right, thank you. So that's what we've observed. As far as projected changes, the highest certainty of global climate models or Earth systems model projections are in temperature as compared to precipitation, as I'll talk about in a little bit. So overall, what we've seen is that summer maximum temperature over the last 100 to 150 years has stayed about the same. But over the last 30 years, we've actually seen a pretty large increase in maximum temperatures. And some of that can be due to variability versus climate change. But what we see from global climate models is a pretty consistent projections of continued warming throughout the year. So what I'm showing on the top figure there, those area plots, show the spread of model projections for annual average mean temperature in the northern third of the state. So we talked about northern Illinois, essentially I-74 north, all right? And what this is showing is that climate models consistently project continued increases in annual average temperature through the end of the century. Now, what I'll say is that you can see the separation there between the area plot in red and in green. Those are scenarios of greenhouse gas forcing or radiative forcing scenarios, where the red indicates the high emission scenario, where we keep emitting carbon dioxide and methane at rates that are pretty close to what we have over the last 30 years. Green are largely curbed emissions rates. So what you can see there is by about 2060, the projections diverge, where we see continued rapid warming under high emission scenarios and the warming curbed under low emission scenarios. So what this means is that overall we have high confidence that we will continue to see temperatures in Illinois continue to increase by the end of the century. However, the magnitude of that warming is highly dependent on emissions now over the next 50 years. And that's going to, I'm going to paint a contrast there with precipitation, just a little bit different, but that is important. The bottom plot is the same thing. It's the same idea here, only instead of it being annual average temperature, it's the number of days annually with a maximum temperature exceeding 95 degrees. So first and foremost, you see, again, consistent increasing trend, a little bit more uncertainty with a larger spread in those models. And that's because we're projecting an extreme instead of an average condition. However, again, you see that divergence between the high emissions and low emissions scenario. Go ahead and go to the next slide. All right, thank you. So impacts, obviously we can think of human health impacts in as far as extreme heat, for example. So if we continue to see our projections are verified and we see that increase in the very hot days, that will have an impact on human health for sure. But as far as temperature impacts, I do want to focus a little bit more on vector-borne diseases. And I just want to give this example here. What I'm showing on the right-hand side is a figure from the University of Illinois Vet Med School in 2018, tick species collected. So you can see that certain species of ticks, American dog ticks, black-legged ticks, they're found pretty much throughout the state. However, the two that I point out in particular, the Lone Star ticks, which are shown in the green part of those circle plots, and the Gulf Coast ticks, which is the purplish part, those are pretty much relegated to Southern Illinois and parts of Central Illinois. Now, the entomology research shows pretty strong connections between the expansion of tick and mosquito ranges and the vector-borne disease that they bring and climate change, especially winter and spring warming and increased precipitation. What we found, and working with the Natural History Survey here at the University of Illinois and the Vet Med School, is that we've seen a consistent increase, expansion and northward expansion of the range of both the Lone Star tick and the Gulf Coast tick into Illinois. The diseases that they carry have come along with them. So for example, heartland disease, which is a pretty nasty pulmonary disease, is spread by the Lone Star tick. It was actually first confirmed in Kankakee County last year. And before that, the most northern county it had been to was St. Clair, which is around St. Louis. So we're seeing that northward expansion of these vector-borne diseases on the back of these ticks. We've also seen a higher prevalence of Lyme disease and West Nile disease, of course, is carried by mosquitoes in Northeast Illinois. The Lyme disease is just because of higher tick prevalence as well as development. Higher development pushes hosts closer together. And we have more interaction between human and hosts like deer, dogs, that sort of thing. The West Nile is because of related dry spells. So actually, much of the literature suggests that we need a somewhat short but acute dry spell in order to get a spike in West Nile cases. Overall, what this is suggesting, though, is as the temperatures continue to warm, we will see a higher prevalence, or projections are indicating a higher prevalence of these vector-borne diseases. Go ahead and go to the next slide, please. And you can skip past this one too. We're going to talk about precipitation now. So observations and precipitation, the bar chart there on the right is showing from the Northeast Climate Division. What this is showing is that the northeast corner of Illinois, the annual total precipitation has increased by about 1/2 to 6/10 of an inch per decade between 1895 and 2019. So overall, the area around the Chicagoland area is about 5 inches wetter than it was around the 20th century. No real surprise to anybody who has a basement in that area. 2019 was actually the first year on record with greater than 50 inches of rain for the entire climate division. A climate division is an area of about 12 to 20 different counties in Northeast Illinois. So a very large area to have an average of over 50 inches of rain. And you can see in that bar chart on the right-hand side, that consistent increase in total annual precipitation. However, just like temperature, the seasonality of that precipitation change is large. And what you can see, I break that down here at the bottom. What this is showing is the change. I say Northwest Illinois because I didn't update this chart, but it's Northeast Illinois. This is in inches per decade as far as trends. And what you can see is that the summer trend is about 4 times larger than that in winter trend, which means that total summer, June to August precipitation has increased over the last 100 years at 4 times the rate as winter precipitation. So we've seen that increase predominantly in the warm season as opposed to changes in winter and fall precipitation overall. Go ahead and go to the next slide. Now we can actually skip this one. I updated this. We can skip that one, and I want to focus on this. Now, not only have we seen an overall change in total annual precipitation, but we're seeing a change in precipitation intensity as well. Some of you may have heard that 2020, the city of Chicago broke its May precipitation record, which was initially set in 2019, which broke the last record, which was set in 2018. So this is the third consecutive year that Chicago has had its wettest May on record. And the year before 2018 that they set the record was 1946. So it lasted quite a while. Most of that record in May this year was set by a 5-day period between May 13th and 17th, where O'Hare recorded almost 8 inches of rainfall. So a really heavy precipitation event. You can see the impacts of flooding on the right-hand side. It's the basement of the, I keep having to say Willis Tower. My mind wants to go to Sears Tower. The Willis Tower, which shut down power for a number of days because of that flooding. Now, here at the Water Survey, the initial estimates of recurrence intervals for storms such as this were estimated back in 1989. We said a 100-year event, like we think about a 100-year flood, has a 1% chance of happening any given year. So we can say, what's the 100-year rainfall for a 24-hour period? And we'd expect to get that 1% or 1% probability of getting it any given year. Well, because of changes in precipitation, we recalculated those estimates just this last year. And so that 5-day period where we had that significant flooding throughout the Chicagoland area, based on the 1989 standards, data as current as of 1989, that was a 50-year event, which means it has a 2% chance of happening any given year. The 2019 standards, that was a 20-year event, which means that over the last 30 years, the probability or the chance of getting that type of event any given year has increased by 2.5 times. Now, it's still a rare event. A 5% rainfall event, a 20-year event is still a relatively rare event. However, what that does is it gives you an idea, if you're thinking about risk for planning, what we're looking at. We're looking at more intense precipitation happening more frequently, resulting in these sorts of floods. Can you go to the next slide, please? All right. We can skip this one too, because as I expected, I rambled on. So what that means is as we get that increase in intense precipitation, we get flooding. We get surface runoff because the soil can only take so much. In developed areas like the city of Chicago, there's very little infiltration. So a lot of that runs off into an antiquated sewer system that was built, by the way, to standards that are no longer the case, those 100-year or 10-year flood situations. What that means is we have more flooding in the Chicagoland area. Flood insurance claims in the Chicagoland area have increased exponentially over the last decade. That's according to the Great Lake Alliance. And payouts totaled $400 million since 2011 in Chicago alone. So not the suburbs, just the city of Chicago, $400 million in flood payouts since 2011. And 2020 data was not calculated in there. That was only since up to 2019. However, as the map on the right-hand side shows, and we can get into this more into the discussion if we so please, climate change is an environmental justice issue as well, because its impacts affect different communities with large disparities. So for example, between 2007 and 2016, almost 90% of flood damage insurance claims in Chicago were paid in communities of color. And you can see the areas of the city in red on the map. Those are the areas where we have the highest frequency of flood damage claims. So the south side and the west side, those areas where we have larger numbers of communities of color, that's where we're seeing the largest impacts of flooding. What the map is actually showing is the number of 311 calls for flood damage over the last 3 years. But overall, that 90% of flood insurance claims paid for in communities of color, that's indicating that we're not seeing an equal dispersion of climate change impacts. So we're seeing different communities whose vulnerability is higher than others being disproportionately affected by flooding. Go ahead and go to the next slide, please. Thank you. So thinking about changes in precipitation as far as projections, these are actually hot off the press. So you're one of the first folks to see this. This is part of a climate change assessment that is partnered with the U of I and the Nature Conservancy. And what this is showing is projected changes by the end of the century in total annual precipitation by season, winter. I'm sorry. I'm sorry, I put the wrong graph up here, but essentially I'll give you the gist here. What this is showing is that we expect to see overall total annual precipitation across the state, those blues and greens, those are indicating total annual precipitation to continue to increase by the end of the century, anywhere between 2 and 10%. And as you can see, the largest changes are in the northern part of the state. Now, when we break these down seasonally, which is the figure I meant to show here, what this is showing is that disproportionately that increase is coming in winter and spring. That's what the models are saying. And actually, there's a slight projected slight decrease in summer precipitation. But the big picture here is that those changes in winter and spring precipitation, that's what the models are showing overall. Can you go to the next slide, please? However, and this is kind of what I show, and I meant if I could have control, I'd just flip back and forth between this slide and the next slide. But what this is showing here, that's okay. Thanks for doing that, though. So what we're seeing here, the plot here on the bottom left is showing those model projections of total spring precipitation going out to the end of the century. And overall, we see pretty tight spread, which is meaning that there's high certainty from these models that we'll continue to see spring precipitation increase, which will, of course, increase the risk of flooding. Now, what you don't see here as much is a separation between the green and the red plot. And what that is indicating is that precipitation, unlike temperature, is not very sensitive to the amount of emissions. So if we lower emissions, what that means is that we overall, the models are suggesting that we will lower the amount of temperature change, but precipitation doesn't respond as easily. Now, part of that is uncertainty in the model, but part of that is the physics behind changes in precipitation. Go ahead and go to the next slide. So we notice the increase in spring, contrast that with the projected decreases in summer. And there are my seasonal plots on the right-hand side. So you see blues and greens on the top, that's winter and spring, large increases. Fall is a wash as far as projections. Summer shows a slight decrease. Now, I know I present this to farmers and they tell me, oh no, are we gonna get floods in the spring, droughts in the summer? That's what some of these projections indicate, but the uncertainty, as you can see in the spread of these models in the bottom left-hand plot, what that's showing is that models have a difficult time projecting summer precipitation. A lot of that is due to the fact that our summer precipitation comes on the back of smaller scale mechanisms that can't necessarily be picked up well by these climate models. And so what I say is that overall, the increase in winter and spring precipitation, those projections have a lot more certainty than the certainty in the decreases in summer. So I would say for the Chicagoland region, if I was planning a water management plans or initiatives over the next 20, 30 years, I would say we will see more impacts related to too much water than not enough. Although the short-term dry spells will still be there. Go ahead and go to the next slide. So I want to end my talk by talking about some global scale impacts that will likely have impacts here in Illinois and actually the Chicagoland region specifically. First and foremost, global sea level rise. So global average sea level has risen by about 175 to 200 millimeters since 1900. However, the vast majority of that has come since about the mid-90s. So we've seen an exponential increase in the amount of global sea level rise since the mid-1990s. Now, one thing about global sea level rise, because it's very tightly coupled with changes in global average temperature, which is relatively easy to model and project, there's very high confidence of projections of continued sea level rise of about an additional 200 millimeters by 2100. Now, that causes a number of things. It changes the hydrologic cycle. But as far as direct impacts to humans, I would say the largest is erosion of seashores and increase incidence of flooding in coastal areas. Now, when I say the impact to Chicago from this will be somewhat more indirect, and because we see a lot more variability in Great Lakes levels like Lake Michigan. So there's not a really great tie to climate change for Great Lakes levels. So we're not seeing the same increase in Great Lakes levels due to climate change that we are in global sea levels. However, go ahead and go to the next slide. What we do get from this, and I know somebody alluded to this earlier, is displacement of millions, if not billions of people globally who live along coastlines that will be either regularly or sporadically inundated. Just to give you an idea, in 2018, there were over 1 million people displaced due to natural disasters in the United States alone. Some of that was hurricanes, some of that was sea level rise caused and flooding, and some of that was wildfires. We'll likely see very similar numbers this year as well, thinking about what's going on out west right now. When we look globally, as far as displacement and refugees are concerned, the vast or the majority of displacement of populations around the world is actually due to natural disasters as opposed to global conflict. Now, with that being said, there is a connection between natural disasters and global conflict, which is something I alluded to. Well, the reason I'm bringing this up with climate change is because, again, we think about Chicago being relatively resilient to something like sea level rise. However, our political systems here in the United States are anything but resilient to mass migration because of climate change. And that's the point I like to drive home. It's a point I like to drive home when I was teaching students from Chicago area to say, yes, we're not seeing the wildfires out west or droughts like they are in Arizona or other sort of massive flooding in places like Bangladesh. But what we will likely experience because of sea level rise, because of our changing climate, is an influx of what folks call climate migrants. I think climate refugees is probably a better term, because these are folks who, again, have an increase in vulnerability, but also less resiliency. And that increase in global sea levels will cause quite a bit more migration than what we've seen over the last 100 years or so. So go ahead and go to the next slide. So with that, I'll wrap it up. Most of these summary points are mainly what we just kind of repeated of what I mentioned before. I think that the biggest thing here is that we have seen impacts to natural and agriculture ecosystems, to human health in the state, and to prosperity. There are economic costs of climate change that are very large. There's actually a report just released this last week that suggested that the economic losses of climate change could have just as much impact as the actual natural disasters part of it. But again, to bring it back and understand again that the impacts are not equally distributed. Even within Northeast Illinois, as I show with those maps, that we're seeing the impacts of climate change affect disproportionately communities of color and other vulnerable communities. And so again, thinking about climate as an environmental justice issue as well as an overall scientific issue. So below is all my contact information. I'll stay online through the discussion, of course, but please, if you have any questions or data needs or anything like that, even if you see a neat story, please feel free to email me at either of those emails. Both come. If you're on Twitter or social media, please feel free to follow and visit our website as well there. And thank you again for letting me come present.
Thank you so much for coming and to presenting. So if you have any questions for Dr. Ford, please put them in the chat and we will get to those in just a moment. I do want to just take a quick mid-round thank you as well that I didn't do before to Hazon, which has been a great partner to Congregation Eitz Chaim's Environmental Committee and even helped fund this program for today and a couple other things that we're doing in the congregation. So a big thank you to Hazon and also a big thank you to you, Dr. Ford, for coming and speaking. Now I'm going to invite up our next speaker. Lydia Scott is the director of the Chicago Region Trees Initiative, RTI, a coalition to improve the health of the urban forest and the quality of life for people in the Chicago region. She directs outreach to public and private land managers, owners, and volunteers on the value of the urban forest, the skills necessary to care for it, and how policy can improve this important resource. In addition to leading staff and volunteers from the Morton Arboretum, Lydia works on various other forestry-related issues and holds an MS degree from U of I. So thank you so much for coming up and speaking. And here I will get your slides right here.
Thank you, Rabbi Camel. It's a pleasure to be here with you today, and it's exciting to see so many of you that after having so many days of rain and a nice sunny day, you should be outside, but we'll capture you while you're here and enjoy your time now. Can I go to the first slide, please? So one of the things I want to talk about is why was the Chicago Region Trees Initiative developed? And it was developed based on a census that was completed by the Morton Arboretum and the U.S. Forest Service in 2010. And it showed us that we had 157 million trees in the Chicago region. There were 2,000 census plots with sites across, randomly distributed across the 7-county region. And it found that we had a 20% tree canopy, and that our most common species are European buckthorn, green ash, box elder, black cherry, and American elm. Now, for some of you on the call today, you will be aware that European buckthorn is an exotic invasive species, and that is 30% of all of the trees in the Chicago region. Yes, I see some thumbs down, that's great. What else is important to note is that green ash was the second most popular species, and green ash, blue ash, and white ash are essentially now completely eradicated from the state of Illinois. It's working its way south due to an exotic insect called emerald ash borer. Box elder is a common tree found in floodplain areas, but it's not one that you would buy at the nursery or plant in your yard. It has very poor structure and is considered to be a weedy tree. It's followed by black cherry, which is a native species and is commonly found in woodlands, but most of the woodland conservation work that is going on right now is removing black cherry, and then it's followed last by American elm. And for those of you that may be in my age class, you remember that Dutch elm disease has been working its way across the US for many years now, killing off elm trees. So you can see we're off to a bad start here as I describe what the urban forest in the Chicago region is like. Another thing that we found with this census was that 73% of all of our trees are less than 6 inches in diameter. Now, for our discussion purposes today, we're going to be talking about why large trees and large trees with large leaves are important to climate impacts as well as to our health. And so when you get to trees that are 6 inches in diameter and less being the majority, that's a challenge that we're currently very aware of. The majority of our oaks are 18 inches or larger, and oaks are our native heritage. They are what our forests were prior to European settlement in the 1830s. And some people will say, well, you know, Illinois is the prairie state. Well, in the northeast region of the state, more than 1 million acres of oak woodlands existed prior to European settlement. So we're seeing now challenges with our oaks. And that's all kind of a grim story, but regardless of the grim state of our forest, these trees are currently providing us with pollution removal of about 24,000 tons per year. Carbon storage, and that's in their structures, how they store carbon and take it from the air and the landscape that they exist in, is about 17 million tons. Carbon sequestration is 677,000 tons per year. These are annual benefits, with building energy reduction of $44 million per year. And the overall compensatory value of our urban forest is $51.2 billion in the Chicago region. So there's a significant benefit to us. And we're going to talk a little bit more about how trees impact our relationship with climate and help us mitigate. Could I have the next slide, please? So when we look at what's happened since we did the 2010 tree census, one of the first things that we have to note, we've talked about already, is that we've lost our ash trees. That's 13 million ash trees in the Chicago region have been killed since 2010. Next slide, please. We have, our canopy has dropped from 20% to 18%, so we're going down. What's important to note that nationally, the average canopy in metropolitan areas is 41%. So you can see in the Chicago area, 18% is nothing to really be particularly proud of. And we do have potential for more, and I'll be showcasing that. Next slide, please. We want to think about how canopies are growing in communities with resources. And Trent talked a little bit about equity issues. We know that canopy is getting smaller in communities without resources. And this is in part due to the, it's a generational impact that started way back when there was a practice in the early days of this century where redlining was common, where people of color were directed to particular neighborhoods and whites were directed to another particular neighborhood. And the result has been lack of investment in those communities over time. And it continues to persist because we all know you can't plant a tree and have it grow to be 300 or 400 feet in height within a couple of years. It takes generations for that to happen. So we're continuing to see the legacy impact of that today. Next slide, please. And then finally, what we know is that as climate continues to increase, the impacts from climate continue to increase on us. And as a result, we're also seeing some changes in aspects to our canopy overall. Next slide, please. So one of the things that I wanted to point out was, and Trent has talked a lot about this already, is that here in the Midwest, we see, you know, we've experienced, and this summer I think is a pretty good example of that, where we had pretty high heat. We've had these intense downpours and then prolonged periods of drought in between. I don't know about you in your neighborhood, but I had, you know, it seemed like every Sunday afternoon I'd drag my hose out to water, and Sunday night it would finally rain. We'd had weeks of no rain. And so it's been problematic as far as drought goes for us. And then in addition to pests and pathogens that are going to increase impacts on our health, we're seeing increase in pests and pathogens that are going to increase devastation to our urban forests overall. And that's coupled with the fact that Chicago sits right here, smack dab in the middle of the United States. We have O'Hare Airport and all these rail lines and transportation hubs that go through Chicago, bringing things from all across the globe to our area. And so it's really critical that we keep an eye out on what's happening, what's coming in. And as we see climate continue to change and we see global warming impacting our climate, we can see that we're going to have some shifts and changes in different things that we see popping up in our area where we live. Next slide, please. So I wanted to just talk briefly about the benefits that trees provide. And at the bottom of this slide, which you probably can't see, but you'll be able to get to it from the YouTube, is a source that you can, it's a literature review on this information that I'm saying up above. So you'll be able to get to this. That we know that trees provide significant benefits to us and to help augment the things that we're doing to improve our impact on the climate. But one of the things that they do is reduce temperature. We know that death from heat is going to be one of the #1 factors of weather-related deaths in the country due to heat impacts. So we're going to see these increased temperatures. And this is especially true in areas where we see high concentrations of impervious surfaces, like buildings and roads and parking lots and things like that. The temperatures there are higher than they are out in natural areas per se. And so we're going to see how trees are going to have an impact on reducing temperature and how we want to be strategic in where we plant and what we plant in order to help offset that. We know that trees have a significant impact on interception of rainwater. And it's not just that the trees are picking up the rain as it falls on their leaves. The root systems of the trees are creating networks and openings and gaps in the soil itself that enable the water to come in and be absorbed into the ground rather than just running off into our streams or into our basements. Tree leaves collect pollution from the air and collect pollution from the water and pull it up into its tissues. And so we see significant impacts in air quality improvements from trees if they're strategically planted. A lot of research is going on, especially down at the University of Illinois, where mental health, they're looking at the mental health aspects of trees and green spaces. For those of us that have been trapped indoors during this COVID-19 pandemic, I think you'll probably agree with me that by the end of the afternoon, after sitting inside all day, you want to get outside and walk where you can be in trees and in nature. And we've sort of co-evolved with green spaces and with nature over time as a species to actually have these relationships with those green spaces and see physical differences that occur mentally as well as physically on our health. Economics is another thing that trees are significantly helpful with. We know that commercial areas, for instance, where there are trees, people will actually spend 12% more of their income in those shopping areas. We know that property values are significantly increased by the fact that trees are located in their proximity. This is particularly important when you look at under-resourced neighborhoods that have low canopies that are also struggling with a number of other variables, including low property values, where if we could get in and get some of those trees replaced, it not only creates a better place to live from an environmental standpoint, but can help them economically as well. Research has been done actually at the University of Illinois as well on crime and how in areas where crime is, where trees are planted, you'll actually see a reduction in crime. Increased community interaction is common. You'll find that when people go out and want to mingle, they find a place where trees are in order to take on that interaction. And then finally, of course, impacts to habitat and wildlife, where wildlife are able to grow and to thrive. Next slide, please. So when we look at these trees, we want to think, and I pointed this out just a few moments ago, it's not just having small little tiny trees around our neighborhoods that are going to be the big thing that's going to improve our situation. It's going to be getting the trees that we have growing bigger and having trees that are larger stature trees common in our landscape. And so when you have larger trees and they have larger leaves on them, they can actually function to provide more benefits and more resources for us to offset some of those impacts that we experience from climate. Next slide, please. So the Chicago Region Trees Initiative was founded by the Arboretum after that 2010 census was taken. And the census describes the trees in the urban forest in the Chicago region as being in a state of transition. I would say it's actually probably a little worse than transition. And what it is a call to action. And so the Arboretum founded the Chicago Region Trees Initiative, which is a coalition of organizations working together to improve quality of life in all neighborhoods, not just upper middle class neighborhoods, but in all neighborhoods across the region. Next slide, please. So these are the 7 counties that comprise the Chicago Region Trees Initiative, and it coincides with the Chicago Metropolitan Agency for Planning. These are the same 7 counties that CMAP works to develop and to oversee recommendations for. CMAP is the planning agency, the regional planning agency that looks at transportation corridors, it looks at building development, it looks at water issues, all those kinds of things that relate to basic planning criteria. And we wanted to be sure that our same boundaries met with CMAP's, and our plan, they have a plan called the On to 2050 plan that's on their website. Our plan, or our master plan for the Chicago region, is also a 2050 plan. Next slide, please. These are some of the leading organizations that advise us, and I want you to just see the variation of the organizations that are on this list. And it's critical because, especially as we're thinking about climate, we're looking at how we can increase trees to help reduce some of these impacts. So for instance, one of the really exciting ones for us is the Chicago Department of Public Health. They're working with NASA and the University of Chicago right now on air quality studies and matching those up with health implications. And they're using our data from the Chicago Region Trees Initiative to identify where we have canopy and where we can have an impact. We also work very closely with the U.S. Forest Service, and they provide input and experience from across the globe, because you may not realize this, but the U.S. Forest Service actually works in other countries as well, so that we can get good input from them. So there's a range of partners here that are really important to us, and you're welcome to go back and look at this slide to see who they all are. Next slide, please. So this is the report that came out of the 2010 tree census, and you can get to this online if you just put in urban trees and forests of the Chicago region. It was developed, as I mentioned, with the U.S. Forest Service and the Morton Arboretum. What you should know is that right now we are in the process of repeating this census, and we're going back to the exact same plots across the exact same 7 counties and recensusing that data right now. We're at about 1,200 plots currently, so we'll be wrapped up about the end of October and should have some very interesting information for us in the beginning of 2021. We believe we're going to see really some very significant shifts just because of the loss of these 13 million ash trees, but there will be other implications as well that we're excited to take a look at. Next slide, please. So when we talk about the census, one of the things that is helpful about that is that it gives us a regional perspective and it gives us information on the county scale, but it does not give us information at the community or parcel scale. And each of the counties applies periodically LiDAR imagery, and LiDAR imagery is light detection and radar. It's flown by a plane, and it picks up little points of height as these planes fly over. And these points create what we call point cloud. And this is an image of a point cloud here, where you can see the fluffy little green stuff towards the front of the slide are trees. And how they know that's trees is that's height that picks up, that's registered on this radar. And so we're able to send this LiDAR imagery off to the University of Vermont, and the spatial analysis lab there in University of Vermont runs analysis for us and gives us 7 different land cover classes. It helps us sort out where our trees are located, where we have vegetation, where we have railroad lines, where we have buildings, we have paved surfaces, bare soil, and water. And this enables us to be able to now look at individual communities and identify where trees are located, where we have potential to plant trees, and where there are opportunity areas to remove or replace impervious surface. Next slide, please. So this is just one simple pie chart, and I'm going to show you where to go for this information, because I'm going to encourage you to go on and look up your own community after we're done here today. But why this is important is this shows you the 7 different land club cover distribution in the 7-county Chicago region. And I actually was a little bit surprised that our impervious surface was as low as it was. I thought it would be higher. And this is in part due to the fact that we still have Will County, Kendall County, and some of Kane County where we have a lot of agriculture going on still. So that's why vegetation shows up to be such a high percentage of our landscape cover. But what's important to look at is in the pie chart on the bottom, when you see that dark green section of the pie chart, that's potential plantable space. So if we look at this 20% that we had in 2010 of canopy, and we know we're down to 2018, or sorry, down to 18% canopy, we have the potential of increasing that canopy by 68% if we planted everything. Now, obviously, we're not going to recommend that we plant across all the golf courses, baseball fields, and soccer fields in the Chicago region, but there is opportunity for increased planting. And where there's most opportunity typically in most communities is in residential areas. We know that 70% of all of the trees in the Chicago region are located on residential property or private property. And we know that that's where we have the most opportunity to increase planting. Now we'll see differences based on communities. So for instance, Alsip, the village of Alsip, is a high priority community for us. Their area where they have the most potential to increase planting is in commercial, interestingly enough. So you see little variations by community as you look overall. Next slide, please. So we're now able to take this information and we put it into an interactive map, and I'll be able to direct you where you can go on and you can click on any of the little the parcels, and this is set up by census tract. So you can click on any little box and it'll give you the canopy cover and a series of other things that you can look at, and we'll talk about what those are as well. But why this is important is that you can see now a quick snapshot of where canopy is located in the Chicago region. The darker bluey green areas are where we have higher canopy, and that's not really surprising, is it? You look up at the North Shore areas of where we have Evanston, Wilmette, Winnetka, Kenilworth, Glencoe, those communities that tend to be quite affluent. Look how much canopy they have there compared with some of the communities that are down on the south side of Chicago or in the southwestern corner of Cook and Will counties. Next slide, please. So this is where I'm going to send you after you get off this webinar today. You'll want to go to chicagorti.org and put in priority map. And you'll be able to go through a series of maps, and I'm going to walk through some of those here with you now. And why this is important is because it gives a story, more of a story for us. It's not enough to know where we have trees planted and growing now. We need to know some of the other information that ties in with this. Next slide, please. So for instance, here's flooding for the Chicago region, and this is all included in this priority map. So the darker the blue, the more flooding is in that area. And you can see where you get into the more developed areas of our region, you're going to see increased flooding. And the reason for that is in part due to the fact that there's so much impervious surface. So when we have these heavy rain events and we have these prolonged periods of rain, even if it's, like last week where we had just constant drizzle for a week on end, these are areas where the water really has nowhere to go except in people's basements. So we want to be sure to identify how we can offset those impacts by getting more trees planted in those areas and providing variations in the landscape so that not everything is built an impervious surface. Next slide, please. Air quality. Air quality is another extremely important factor. And when we think about trees and the benefits they provide, we know they provide air quality benefits. So on this map, you can see where it's more of that darker purple is where we have poorer air quality. Now the white blotch in that sort of middle section, upper middle section of our map there, that's O'Hare Airport. And then the little white section down below is Midway Airport. And so you can see the significant air quality impacts that occur because of those two facilities there in our region. Again, you're going to see, and we'll look at this at the end as we start to layer some of this data, where you see we have these poor air quality, increased flooding, increased heat, low canopy. Those are areas where we really need to be focusing and providing assistance. Next slide, please. This is vulnerable populations, and vulnerable populations are populations where there are low income, a high percentage of non-English speakers, an increased percentage of the elderly or children, would be vulnerable populations. And so we've merged a series of data in order to get to this vulnerable population. But again, you're going to see some correlations as where these vulnerable populations live and how what we want to see happening in the Chicago region can have a direct impact on those populations. Next slide, please. So this is a heat map, and this is not the one that's on our website, but I wanted to show it to you just so you could see. When you look at temperatures across the Chicago region, it's the map on the left, and then the map on the right is our canopy map. So where you see the blue lines and the map on the left, you'll see dark green lines or dark green sections, and those are where trees are located. When you see areas of yellow on the map on the left, and you see pale green on the right, those are areas where we have low canopy, but we also have extremely high heat. So the red areas are where we have the most that most intense heat. And again, you're going to see those are going to be areas where we typically too have lower canopy. Next slide, please. So on our website is a map, it's called our temperature map. And I've given you the location here so you can look that up. And this little circle is a little spyglass that you can move across the surface of this map and look at temperature change and how it relates to canopy cover. Why this is important, again, is to showcase where do we have opportunities to increase planting to reduce some of these temperature issues. Next slide, please. And this is the compilation of some of this data that we're talking about. So again, we don't have our health data loaded in here yet. That's something that we're currently working on. But you'll be able to go to that first map that I showed you where it was the prioritization map, and you'll be able to go through the different maps. You can stop at any page. You can zoom in, so anytime you click on there, you'll be able to pick up, it'll give you the name of the village or city that census tract is in. And it'll give you, if you're looking at canopy, the percent canopy. If you're looking at temperature, it'll give you the temperature. If you're looking at water quality, it'll give you the water quality scores. And then you can move around the map and see how those different cities compare to other cities overall. Next slide, please. So we've looked at where we have canopy and where we have environmental impacts to socio-ecological impacts that we need to be aware of. The other thing that we have to be aware of is that trees don't grow on their own. They do in natural areas, and even that we can talk a little bit about. But where we're in an urban environment, what we see is there's capacity to care for trees. And these are surveys that we send out to municipalities, all the municipalities, the 284 in the 7-county Chicago area. And we ask them 89 questions every 5 years and ask them to tell us what are their biggest challenges. And so this one was done in 2014 when emerald ash borer was at its height, and most municipalities had very little resources to plant trees, but were actively engaged in cutting trees down. So we asked them, what are the things that you need? And the thing they said they needed most was additional staff. They weren't able to handle what was coming at them, that they needed more finances for trees, that they needed more operating funds, and they needed more trees. Well, why would they need more trees, you might think? One of the challenges that we have is in 2008, when the recession hit, nurseries, because they weren't able to sell trees, communities quit buying trees. So nurseries ended up having to cut down trees in the fields because no one was buying them, and they would get too big for them to be able to harvest. And it doesn't instantaneously happen that we get new trees. It takes almost 10 years to get a new supply of trees in place. And so at the height of emerald ash borer, when the economy was starting to turn around and communities had money to plant trees, now they weren't able to buy the trees because the trees weren't in production yet. So there's a number of things that happen with, it's this interconnected web of things that are going on. Next slide, please. So we asked them about their forest staff capacity and their management plans, and we've mapped those. Next slide, please. And that's on our priority map as well. We asked them budgets per capita. And so this you can see in the city of Chicago is sort of the mid-range, but we have some of these communities that are way up north, like Zion and Waukegan, that are under-resourced communities that have fewer resources. And you'll see that there are many areas where we don't know. We're not getting responses from them. So it's limited knowledge that we have. Next slide, please. All of this analysis is on our website, and I gave you the link for that. So I'm going to move past this slide. Thank you. So as I mentioned before, when you go onto the priority maps and you click on those links, any of those, I just clicked on Alsip because that's a high priority community for us. And so when you click on that parcel, it'll tell you that priority rank, and this is for Chicago Region Trees Initiative, is very high. And they're very high because their canopy is reasonably decent. It's 19%, that's 2010. So we're expecting it's closer to 16, 17% now. But their flood susceptibility is 8.23, which means, and 10 is the worst that you can get for flood susceptibility. So they're very high for flood susceptibility. For surface temperature, they're 79 degrees. And what this temperatures were taken across the region over a short period of time. And what we could see is fluctuations. And so what we see as much as a 10-degree difference between communities across the region with respect to temperature. And when you get to really high heat, 10 degrees is a lot. And even, a couple of degrees is a lot. So it's something to be aware of. The other thing I'd like to tell you about percent canopy is that we have communities that have 3% canopy up to communities that have 66% tree canopy. So you can see there's a huge disparity across the region with that. Now, it happens that the community that has 3% canopy is one that is very heavy agricultural. But if you go clicking around on the south side of Chicago, you'll find that we have communities of 8 and 9% canopy, and those are in heavy urban areas as well. Air quality is a very high factor of 3.6, and their vulnerability ranking is a medium, meaning that they don't have real high percentages of vulnerable populations, but it's something that we want to keep an eye on. So again, when you go on to look, you can click on any of those little census tracts and get information on any of the communities with respect to that information. Next slide, please. So another important factor for us to take into account, we need to come just a little, there you go, is the projected growth. This map was provided to us by the Chicago Metropolitan Agency for Planning, and the yellow is where they project growth occurring in the Chicago region over the next 30 years. It's very interesting because, and when I talk about this in other parts of the country, they'll say, oh, you'll see dramatic declines in canopy cover then as this development takes place. Well, actually in the Chicago area, we're going to see an increase in canopy as a result of development. And that's because most of these areas that will be being developed are agricultural areas, where they already don't have any trees. They have lots of cornfields, but no trees. And so we're expecting to see some increase in our canopy as a relationship to projected growth in the Chicago region. Next slide, please. Now, I talked briefly before about, and I'm sorry to give you all this background information, but it's going to give you context for what we're trying to do. The oak ecosystems in our region are not regenerating. Remember when I said that the majority of our oaks are 18 inches or larger? What we're finding even in our natural areas is that the little tiny oaks, as they start to grow, will all of a sudden disappear in the landscape. And what's happening is a couple of things. One, there's a lot of deer that are browsing these new young oaks that are coming up. So they're delectable little treats for deer and other wildlife, but it's also an enclosed canopy. Oaks need a tremendous amount of light to begin to grow. They need that to get energy to their root systems in order for them to take off. And so we've developed a plan called the Oak Ecosystem Recovery Plan that's looking at oak development in our region. Now we're down to about 117,000 acres of oak ecosystems in our region from the 1 million acres that we had in the 1830s. And how do we know that? We took the survey notes from the surveyors that were walking across the United States in the 1830s, and they recorded what trees they passed as they walked along surveying the US and in particular Illinois to get ready to sell off parcels of Illinois to the public. And so we've been able to map those. And this map shows you the little yellow sections on the map are where we historically had oak ecosystems in the 1830s. And then the taupe area is the area that we had oaks in 1939. And then the dark blue little kind of, they look almost frilly like, is where we have oak ecosystems today. And then there are some purple lines that connect those. What we've done is we've developed a strategy to identify where these remnant oak ecosystems are and where, so that people can actually go onto the interactive maps and see, am I living in a historic oak ecosystem? Am I adjacent to an oak ecosystem? And what practices should I be implementing on my property to improve the health of that oak ecosystem? And then for the corridors that connect them, we're looking at those as opportunity areas to educate the public about how they can increase planting native species on their properties in order to connect these oak ecosystems. Because in order them to be healthy, you can look at the yellow blobs that, that were originally there. Those were pretty significant in size, and they're much healthier because they're able to work as an intact unit. What we're finding now is we have all these fragmented little plots of land across the region that have oaks in them, and we're trying to sort of reconfigure those by encouraging people to manage their properties in a way that supports oak ecosystem health, because we don't want to lose our historic native heritage of our oak ecosystems. The other thing that's important to think about with that is that we're in the Mississippi Flyway, so that as birds are migrating across the globe, they stop here in Illinois. They look for oak trees that host native species, and so that they have insects to eat and something to sustain them as they continue on their migration path. Next slide, please. So finally, and how this ties into climate, in 2014, we did a report and a study with the Northern Institute of Applied Climate Science. So they came here, they took our species composition based on our census, and they sent that off to scientists at the US Forest Service, who began to look at vulnerability of our trees to potential climate change. And then we did a series of workshops on identifying adaptive capacity, meaning what can we do to help increase the survivability of our trees in our Chicago region. What kinds of practices do we need to be undertaking in order to improve and reduce those impacts that we're experiencing from climate? And so if you can get to this guide also online through the US Forest Service. If you just type in the name for it, it'll pop right up for you. And it lists all of our tree species in the Chicago region. It gives them their vulnerability ranking based on their ability to adapt to a changing climate. Overall, our trees, especially our native species, are pretty well adapted to a wide range of growing conditions, so we're not as concerned about them. There's a handful of species that are going to be a little bit more stressed. And one of the challenges that we have for our tree species is that we know that things are getting warmer, but we still occasionally, because we're in Illinois, we'll have these cold snaps where we'll have a week or so in the winter time where the temperatures will drop really low. So we can't just automatically move tree species from the south and start planting them here in the Chicago region, because we're going to continue to have these cold snaps. So and I'm asked this all the time, what do you suggest I plant, because of climate change? And we say over and over again, and I'll talk about this more, is broad species diversity. The broader the species diversity you have, the less likely you are to be impacted either by a changing climate or pests and pathogens that are coming our way. Next slide, please. So all of this information that I've been telling you about, we've collected, and we spent 3 years working with community groups and stakeholders across the Chicago region to develop a strategy for how are we going to turn this around? What are we going to be able to do to make a difference in the Chicago region? And the master plan is located on our website too, so you can get to that. It's a fairly extensive document, but really what it boils down to is that we have to get everybody involved. It's not just a municipal issue because only 30% of our trees are on public land. We need to be able to get our neighbors and our friends involved as well. And so the strategies need to be applicable to the everyday citizen. We also, obviously want to think about how we're impacting policy and how we're directing things that are happening here in the region. And that again is where we come back to individual citizens. The people that you vote into office in your community are making decisions about quality of life for you in your neighborhood. And so we want to reinforce that, and we'll talk a little bit more about that. Next slide, please. So there are 4 goals for the Chicago Region Trees Initiative. The first is to inspire people to value trees. If people don't understand why trees are important, we're not going to be able to succeed at any of the other goals. And so that's really our primary off the ground first start, is to get people to understand why trees are important. We have to increase the region's canopy in order to increase the benefits and services that the trees provide to us. We need to get that canopy percentage up there. And we need to reduce threats to trees. This includes climate. So what can we do to make our trees more sustainable and more adaptable to impacts from climate, as well as impacts from us as humans on top of that? And then finally, to enhance our oak ecosystems. Next slide, please. So the first thing we want is we want everybody to know what they have. So I'm going to send you back to our website again, and on our landing page, you're going to see in the upper right-hand corner, interactive canopy map, which is that map on the left side of our screen. When you click on that map, it will take you to another map, and you'll click on your community. So I clicked on Lombard because I believe your congregation is located in Lombard. So when you click on Lombard, you'll get this little box that will come up, and it'll say forest summary information. I'll come back to that. But canopy average is 26%, so that's not too bad for the region. Impervious surface is 36%. Annual benefits from your trees is $1.7 million. And then your carbon stored is $4.5 million worth of carbon storage. When you click on this more info box that's at the top part of that little summary, next slide, please. It'll take you to this. And this is a very wordy intensive, and it's 13 pages long. So, but most of it is graphs and tables that you can see specific to Lombard, what your potential plantable space is, where you have the best opportunity for increased canopy, what your species diversity is based on your community inventory, what your percentage of or what the impacts are from buckthorn, that invasive species that we need to be aware of. What's the dollar value of your urban forest for you? And then also, where were the historic oak ecosystems in Lombard in the pre-settlement days, and where are they now? So it's a pretty extensive data set for you to look at, but I would encourage you to take a look. And there's one in there for every municipality in the Chicago region, all 284, and each of the 50 Chicago wards are also located on that map. Next slide, please. So, you know, you're going to learn about your forest. You're going to see what you have and why you have it. And there's a fairly lengthy explanation in there about it. And if when you're looking at it, you have questions about that canopy summary packet, shoot me an email. I'd be glad to, provide any explanation I need to. One of the things that we need you to do is we need you to care for the trees you have. It's not enough to plant new trees. New trees take a long time to get to larger size. What we need is the trees that we have to grow bigger. And what that is going to require is that people are aware of the fact that they have to water their trees. You'd be surprised the number of people that think just because the trees are out there and the leaves are green that they don't have to do anything about it. But what we know about trees is that trees take a long time to show impacts. So it may be this summer's drought that will show up next summer in decreased foliage on those trees or sections of those branches that are died off. Or you may see it late in the fall when we might see earlier color change in our leaves than we would typically see. So watering your trees is something that we want people to be very aware of. Trees need to be mulched. In urban areas, urban trees have to be very durable, very sturdy stock. And so there are a handful of trees that really do well with that, but most of the trees do not. So we need to provide the best growing conditions possible. We need to make sure that our trees get mulched. They have 3 to 4 inches of mulch around them, and that helps keep the moisture in the summertime. It helps reduce the heat as well. What you want to be sure though, and this is really important, so you have to pay attention, the mulch did not touch the bark of the tree. So when you look at this little image here to the left, you see there's a little gap between where the mulch is and where the trunk of the tree is. Next slide, please. The other thing that we need you to understand is that we need to expand species diversity. So we talked about ash trees. 20% of all of the street trees in the Chicago region were ash. So we lost 20% of all of our street trees. Guess what? Maple is 32% of all of the street trees in the Chicago region. And guess what? In Ohio, there's a little bug called Asian longhorn beetle that loves maple trees. He loves other species too, but he really likes maple trees. So what we need to do is be sure that we're planting broad species diversity. So when you say to yourself, I want a beautiful fall tree like my neighbor has, it's an acer or a maple, we don't want you to plant a maple. We want you to plant something else. We want you to plant a frontier elm or a tupelo or a sweet gum, not a maple. So when we look at the species diversity and we have all land uses, municipal trees and private property trees, when you see all land uses, see Rhamnus cathartica, that's the buckthorn, 28.2%. And then when you look at municipal trees, you see that Acer is 32.9, and you don't see buckthorn or Rhamnus on their list at all. Why is that, do you think? Well, municipalities only inventory trees they maintain. Because they don't take care of buckthorn, they don't count it. That doesn't mean it's not there. It is there. When you look at private property, and we did private property inventories to over 800 properties across the Chicago region, again, Rhamnus cathartica or buckthorn pops up again. But look again where Acer comes in. Acer are those maple trees. And so maple trees are going to be a real challenge for us. Do not plant maple for a while. Fraxinus is ash. We've lost our ash and you can't buy it. So you don't have to worry about that one for a while. Gladitia is our honey locust. Honey locust is another one that's very overplanted. Tilia, which is linden, is another one that's quite overplanted. So you want to look for things that are not on this list that are more diverse. Next slide, please. So how do you know? Well, this is a street that had ash trees on it. Can you imagine what that street looks like now with all those trees down? This was not fall, this was not winter, this was in the height of summer. All those trees are standing dead trees. Next slide, please. So we get requests all the time saying, you know, what do you want me to plant? What should I be planting? And so what we did is we built what's called the tree selector. And this is available on the Morton Arboretum website so that you don't have to know what species of trees or anything about them other than what you want. So for instance, this one asks, what is your site? So you'd click residential or parks if that's where you're planting, or if it's a street tree, you'd put your parkway, or if it's in the middle of a road, you'd put median. And it'll give you an opportunity to check that off. Is your tree going under power lines? You'll put yes or no. You describe the sun exposure. Is your tree in full sun or does it have partial shade? And it'll ask you a bunch of other questions. What size tree do you want? Do you want spring bloom? Do you want fall color? Is your site exposed to salt from the road? You check those boxes and then click submit, and it'll give you a list of species to choose from. So now you can look at species diversity rather than just looking for a maple. Next slide, please. We also have resources available for pests and pathogens. This little insect on the right is called spotted lanternfly. It's in Pennsylvania now, and it's a significant challenge, and it's coming our way. It happens to like hops and grapes, so if you're a wine drinker or a beer drinker, you're going to be in trouble here soon because that little insect is coming to take over your crop. And then the other thing on the left side is Management of Invasive Plants and Pests of Illinois. This is a resource that's available on our website, but it'll talk to you about how do you manage buckthorn? How do I know what I should be looking out for? And what time of year should I be taking care of these things? So it gives you a step-by-step guide, and there's phenology in there as well. So it'll show you seasonally what you should expect. Next slide, please. When we talked about buckthorn before, people don't realize often that because it's not green doesn't mean that it's good. So when you look out your window and you see this solid thicket of green leaves in your backyard, it could very well be an entire thicket of buckthorn. We want to encourage people to plant other species. So we've developed a series of guides. This one is the Healthy Hedges Guide that talks about removing buckthorn and what you can replace it with. So you can look online to see what kinds of species would be appropriate to replace them with. What's important to note about buckthorn is that it actually creates a chemical in the soil called emodin. And the emodin in the soil will actually keep salamanders and frogs from being able to complete successful gestation, meaning that they die in the embryo stage. They can't go to a full stage. So it's a chemical that's causing problems in the landscape. It not only impacts small insects and small animals, but it also restricts other species from growing around it. It's what they call, why can't I think of the term? I can't think of the term right now. And it puts out a chemical that restricts other things from competing with it. It makes it extremely viable, that its own species in the landscape, but it keeps other species from being able to grow there. So anyway, this is a guide for you, and we have this available online, but we also have available as a handout, and it's available at most of the garden centers around the Chicago region. And the goal there is to get buckthorn out of the landscape and get things that are more desirable and can be supportive to the health of our ecosystems. Next slide, please. We talk about native oak ecosystems. This is the 1830s map, so you can see what oaks looked like across our area in the 1830s. We need to incorporate more native species into our landscape. Next slide, please. And so, for instance, this shows the oak ecosystem recovery plan. In each of the 7 counties, we've asked each of the forest preserve districts to identify one priority oak ecosystem that they would like to focus as a priority for them. And so in DuPage County, which I'm assuming most of you live in DuPage, it's the Green Valley Forest Preserve is what they've selected as their priority oak ecosystem. And why that's important is because now the forest preserve districts are providing more direct outreach to landowners within the county and especially around that forest preserve to improve the management of their properties in order to support and improve the health of those ecosystems overall. And so as we get this moving and they become more successful with this, we'll be able to increase these to other areas in addition to just these one in each of the counties. But just so you know that each county does have a priority oak ecosystem that they're really focused on trying to improve. Next slide, please. And why oak trees are important. So for instance, oaks support 534 species. Why is that important? Because the oaks themselves are what they call a keystone species. So these 534 other species that grow with oaks rely on oaks for their survival. We see cherry or plum. Now remember, black cherry was one of the highest in our region for concentrations. It supports 456 other species on down through the list. And so when we plant native, we're supporting local habitat and local wildlife habitat. So we want to be sure that we're doing that, as well as supporting these migrating birds and other insects that are coming through in our area. Oaks, when we looked at the census, red oak showed up as only 2% of the total canopy cover in the Chicago region, and none of the other oaks even came above 2%. So we have room to increase the concentration of oaks and other native species in our landscape without making them too many in our landscape to reduce diversity. So we've got a ways to go before that'll become a problem. So we encourage people to increase planting of oaks on their property and other native species to support this matrix. Next slide, please. When I talked before, another thing that you can do is looking at who you've elected to office. And for some of you, it might just be as simple as calling your municipality and saying, do we have a municipal forester? Or it might be as easy as going online and looking at where your ordinance is. And I have a slide on that coming up. What we want you to do is we want you to be sure that you understand why trees are important to you and your community and how the impacts from climate are causing challenges to your quality of life and how these trees are helping to offset some of those challenges. So again, you want to be talking to your elected officials about air and water quality, and they often aren't as concerned about that. When you talk about flooding, their ears really start to perk up because there are dollars involved with that. If there's flooding in the community, they become very excited about the fact that, oh, we're gonna have to do sandbagging, or we're going to have FEMA involved or some other entity that's going to create some kind of a financial challenge on the municipality. Air and water quality aren't often as big a concern for them. Property values are a concern for them. So we know that increased tree planting in our communities helps improve our property values, and individual homes themselves can increase their sale value by 3 to 10% by simply having trees and representative landscaping around them. We know energy usage is reduced, which helps decrease your energy bills. Mental and physical health is increased, heat is reduced, and flooding is reduced, and not to mention habitat aesthetics. And again, when you look on your individual community summary packet on that map that I sent you to, you'll be able to see 3 variables that's shown on this table, this slide right here, that showcase what the benefits are to your community for the trees for 3 things. Next slide, please. And then this is the last area, and this is where I was said before. If you go onto your community website, and I just pulled Lyle up, but for whatever municipality you're in, if you go to your community website and you put in the search box municipal code, so you can put in code, you can put in ordinance, you can put in statute, you can start to look at what kinds of regulations you have in your communities around trees. In the in the 1970s, I live in Lake Forest, so I'm up north of you all. In the 1970s, there was a guy that moved to Lake Forest who used to be a TV star called Mr. T. Do any of you remember him? He came into Lake Forest and he cut down 150 20 to 25 inch diameter oak trees on his property because he didn't want any trees around his house. At the time, the municipality couldn't do anything about it because they didn't have any kind of an ordinance that regulated what kind of devastation somebody could cause on their property. And to this day, still many communities don't have a private property tree ordinance, but many do. For those communities that do, they can now regulate just like they do when you put in, you change the grade on your property or you want to re-roof your house, it requires a permit. For some municipalities now, that's a requirement, so that the recognition is that those trees that are on your property have a direct impact on your neighbor's property, such as with the stormwater or flooding or air quality or heat. So you want to take a look at what ordinances you have, and there are two things that you want to look at. You want to look for tree preservation ordinance, and you want to look at tree development ordinance, so that your community, to see how your community stacks up. And then you can go ahead and advocate for that and push your elected officials to support trees in your community. So trees overall, as we know, next slide, please. We know that bigger trees are going to provide bigger benefits. We've identified a goal of increasing our canopy by 4%, which doesn't sound like much. That's to get us to 22% by 2050. That's what the biggest growth for us is going to be, getting the trees that we have growing to be bigger. But it also means that we have to plant 22 million trees by 2050. That's 2 trees for every single person living in the Chicago region. So for each of you on this call today, you have at least 2 trees to get in the ground for yourself. And then you should be thinking about putting in 2 trees for somebody else, especially for those under-resourced neighborhoods that we have on the south and west sides of Chicago and in northern Cook County and some of our rural communities. They need help getting trees in the ground. And if you can't do it, you can contribute to the tree bank. We have a tree bank where we take donations and we take that money out and plant in communities that are under-resourced and need assistance. So you got quite a few things that you have to do today. One is to think about caring for your trees. The other is to advocate for trees in your community. The other is to be sure, if you're planting something, to plant it correctly and to keep it watered and cared for, but also to plant broad species diversity so we don't keep running into these catastrophic losses. And we want that particularly to take place in order to offset some of these challenges that we're experiencing with our climate. Next slide, please. If you want to get in direct contact with me, my email is listed there. I'm glad to take questions or comments at any time. We get emails from citizens across the Chicago region, many of them every week, and we're glad to help in any way we can. Thank you for letting me present to you today.
Thank you so much for presenting. So now I'm going to invite up Rick Schoenberg, who's going to just tell us a little bit more about how what we can do. You're still muted, Rick. There you go.
Thank you. I'm Rick Schoenfield. I'm the chair of the Environmental Task Force. I'm going to spend a few minutes talking about some of the good work that organizations are doing to combat climate change, with an emphasis on some organizations which are trying to protect and preserve forests in general, forests and rainforests in particular. Just briefly, I wanted to let you know that both my understanding and my passion about this were greatly increased from 2 experiences. One was a trip with the Rainforest Trust 2 years ago, and you'll see a couple of pictures about that as to make the points I'm trying to make. And the other was that I had the opportunity to be at a dinner almost exactly a year ago where Jane Goodall spoke. And most, if not all of you, I imagine know who she is. I wish I had her energy. She's in her 80s, and before COVID happened, she was on the road 300 days a year, speaking to raise funds and educate people about the environment and about climate, which has been her focus for years now, while the chimpanzee research that she first became famous for still continues. So the slide you see just mentions some issues, problems that are causing deforestation. If you come back to the first slide, please. Logging, cutting down forest for agriculture in general, and for some years now, palm oil in particular. And then of course, fires, both intentional and natural. Under natural, we can include accidental, and those fires which are quote natural, but one of the causes also, as has been going on in California, human activity, human development, electrical lines, more and more homes in places, more and more impervious surfaces, as Lydia was talking about. So when we get into the issue of battling deforestation, you have to consider who is it who controls the land? Is it the government? If it's the government, are they following good public policy, or are they just interested in short-term tax dollars? And that assumes no corruption. Is it local people? If it's local people, you need to have local people who buy into preserving the forest. Now, they may not be thinking in terms of climate change in lots of places around the world that much, and here too for that matter. But the effects of climate change, the very immediate effects of climate change, are things that can really affect people's attitudes and the general health of the ecosystem. Jane Goodall at that dinner told us a story about how in the area where she's worked, in particular in Africa, conversations with the people who live there led to their now being very much protective of the forest as they realized that the forest was preventing soil erosion and helping their farming activities. And additionally, maintaining the forest and maintaining the soil was going to help prevent flooding from the river. So she talked to us about a conversation with the grandmother, and the grandmother said she was happy to walk extra miles a day to where she needed to do her farming and leave the forest intact, because by doing that, she was helping to prevent the river from flooding and washing away the schoolhouse that her grandchildren went to. So really, when people see the immediate impacts, it doesn't have to be, while we're all very interested in the science and everything else, it doesn't have to be a matter of talking to people necessarily about capturing or sequestering carbon. What is it doing to them in their communities right now? Next slide, please. All right, so this is taken from the Rainforest Trust. So tropical deforestation accounts for up to 15% of net global carbon emissions each year, which is the equivalent of what every vehicle, ship, and plane combined are doing. Preventing deforestation would keep all that carbon safely stored. Halting tropical deforestation and allowing for regrowth could mitigate up to 50% of net global emissions through 2050. And of course, it would also have the benefit of protecting habitat for endangered species and preserving biodiversity. One thing that I just found that's not on the slide is that according to a UN panel, forests are primarily responsible for capturing almost 30% of annual global CO2 emissions. So in short, they're just hugely, hugely important. Next slide, please. All right, so I picked out a small number of organizations to talk to you about. So first, there's the Nature Conservancy. I think I've misspelled there. Nature Conservancy, which has been mentioned by our speakers already today. They do a number of things, but their largest activity is conserving land. In this case, it's not just forest. Sometimes it's forest, sometimes it's grasslands, wetlands, prairies. But their work is in putting that in trust and keeping it in its natural state, all of which is helpful. And some of you may already be familiar with them. Then there's an organization called Vital Ground. Vital Ground operates in Montana and in the northwestern states, not along the coast, but on the interior. What Vital Ground specifically focuses on is acquiring land, putting it in trust with the specific purpose of creating and maintaining healthy habitat for grizzly bears. What does it have to do with climate change, you may ask? And the answer is, if you have a healthy environment for apex predators like grizzly bears or whatever the apex predator might be, you will have a healthy environment. And in this case, you will also maintain more forest. The Rainforest Trust funds and assists in creating projects around the world, always with a local partner, never owning anything on their own. And they have acquired for their local partners millions of acres of rainforest around the world. And I'm going to come back to them in just a moment. Under the umbrella of the Jane Goodall Institute is a program called Roots and Shoots, which is specifically for children, young people, not just small children, but young people, to educate them and to help them do projects that are helping the environment by taking positive action. And the last one that I wanted to mention has already been mentioned, Hazone, which has been good enough to give our congregation a couple of grants this year, and which helped publicize our program, and which basically supports Jewish organizations to promote pro-environmental matters and environmental education. So if we can go to the next slide, please. Okay, so this is a photo taken, this is along the Kinabatangan River in northern Borneo, which is where I took that trip. And what it shows is just a quick picture of what a healthy rainforest looks like along this river, which is the main river in this part of Borneo, which is one of the largest islands of the world. Next slide, please. Okay, this shows along the same river system where the rainforest has been cut down, and those are oil palm plants. Palm oil is in just a ton of products. It's probably in something that all of us have in our homes now. It's not that it's going to stop. But what's important to know is that it's taking too much land, and and that's a problem, and just means that it's all the more important to try to preserve and reacquire land for the rainforest. And this is going on around the world. Next slide, please. Going back to what a little piece of healthy rainforest looks like, same river system. When you have healthy rainforest, you get events like this. This was a herd of elephants. They actually call them pygmy elephants there. Not that they're that small. Crossing the river and enjoying their home in the rainforest. And I thought I should put in a picture on the brighter side here. Next slide, please. All right, so to get back to the big question of what can people like us do? Well, this is an example of a current Rainforest Trust program. They're trying to help over 100 communities, indigenous communities, acquire legal title, acquire legal title to the land that they're on, involving over 6 million acres. The cost, and this is rather amazing to me, is only 76 cents an acre. Now, some of their projects, the land cost much, much more than this. But I wanted to give you an example of how this major project actually costs so little per acre. And then the last bullet point there talks about how many million tons of CO2 equivalent would be stored, and it offsets almost 25 million, the average emissions of almost 25 million cars in a year, and that's based on the EPA formula of of 4.6 cars per metric ton. I'm trying to go a little fast here so we have time for our Q&A. The next slide, please. Okay, this is a picture of part of Kenyer Lake, which is on the Malay Peninsula. This was an area that was the site of a Rainforest Trust project that's been fully funded. I just wanted to give you an example of a funded project. This is only a small piece of the area. It's a large area. Next slide, please. Okay, so here the local partner was an organization called RIMBA, which continues to do a variety of projects. You can find them on the internet. I'll just tell you briefly, because we met them. It's an amazing group. Everybody was in their 20s, 30s, maybe early 40s, maybe not. They were doing everything from catching poachers to influencing government policy, which is what was necessary for this project. So this project, which cost $10.43 an acre, created a new park of over 200,000 acres, or newly protected over 200,000 acres rather, and upgraded almost 32,000 acres to state park status. It's very interesting. If I can take a minute and tell you about upgrading it to a state park status, the government there was not that enthusiastic. The government there was like the fact they were getting tax dollars from the loggers who were doing very destructive logging, which included dragging the logs down to that lake, which brought silt into the lake in a substantial amount. And so things were sort of at a standstill. Each Malaysian state has a sultan who doesn't hold political office, but is influential as both a community and religious leader. The sultan was sympathetic to sympathetic to the environment. They invited the sultan out to take a look at the project. The RIMBA representatives quoted the Quran about maintaining the purity of the waters. That brought the Sultan completely around to trying to help them. He literally made a phone call and the state government acted and the state park was created. And as you can see, that's also offsetting the yearly emissions of almost 900 million cars a year. So these things really do work, and there are many of these projects that are going on. You can look at the websites of any of the organizations that I've mentioned to get more details, or you can, or I'm happy to talk to you about that for anybody who'd like to. All right, so next slide, please. All right, so through our website, the Environmental Task Force has created a list of various things that individuals can choose to do. It's a variety of different things involving recycling, reusing, reducing our carbon footprint, and supporting good organizations. And we will continue to add to that list as time goes on. You can find it by clicking on Tikkun Alam and then clicking on the environmental link, and then you'll see another link to the list. I just checked for my own reasons the other day about how do you buy furniture sustainably. And I was pleasantly surprised to find when you just ask that question in Google or put in those words in Google, you get a lot of information. So in the future, we will present more environmental information and programs. It's our intention to have more information on the website for National Recycling Day in 2 months from now. In particular, I want to thank Mary Ann and Rabbi Camel and all who you've heard today. Also Mary Hasten and Cynthia Mark Hummel, who were instrumental in putting today's program together. If you want to join the Environmental Task Force, you can contact me, and that's my email there, rschoenfield@aol.com. And with that, I'll turn it back to Rabbi Camel for discussion.
All right, thank you so much. And I am mindful of the time, so we'll get to some of the questions that we had that were put in our chat. Our first question coming from going back to the discussion about ticks, where we said, given the migration of ticks, are physicians going to be trained to diagnose Lyme disease? If that's something that you know, Dr. Ford.
Yeah, really good question. I can pull on my expertise not as a climatologist, but as a husband of a adult medicine nurse practitioner. So we lived in Southern Illinois for 4 years, where the prevalence of Lyme disease wasn't as high as it is in Northern Illinois, but the incidence is. So the percent of people who come down with it. And yeah, so allergists who are specially trained in diagnosing not only Lyme disease, but other sorts of diseases such as alpha-gal, which is you may have heard of it. It's a disease where an enzyme injected from a tick bite makes folks allergic to a protein found in mammalian meat. So essentially makes people allergic to eating any sort of mammal meat. Those sorts of diseases that are sort of developing, as well as those that